Hello, hello, ladies and gentlemen. Root Beer here with the 2002 Fermat paper. We're starting Part C. Those are the last 5 questions, and they are the hardest questions on the contest. So hopefully you have either in the past or you're about to clicked the link in the description for one of my videos and gotten a copy of this contest for yourself. Try these last 5 questions. They're the really, really tough ones. We're going to be starting with question 21, but you should try that one before watching this video. Try 22 before watching the next video, and so on. Really give them a good go before you watch and see how I approach the problems. Okay? So, without further ado, here's question 21 on the 2002 Fermat paper. So, if square root of 3 over 1 times 5 over 3 times 7 over 5 times, and then this pattern continues on. We're only using odd numbers, and we start with 1 on the bottom, and then the next odd number, 3. And then we duplicate that 3, and then the next odd number, 5. Then a 5 on the bottom, and we duplicate that odd number, it's 7. And we go all the way up to a certain pair of odd numbers. 2 to the n minus 1, which is an even number minus 1, so it's going to have to be odd. And 2 to the n plus 1 on top. So we got a multiplication of fractions, and then we square root the whole thing, and we get 9. Then the value of n is, so we want to figure out how many of these fractions do we have to multiply together and then square root in order to get an answer of 9. Not a bad question. It's a little hard to work with right from the get-go, because if I don't know what n is, I don't know how many of these terms I should be writing out to try and manipulate as an equation. But this is an excellent example of something called a telescoping problem or a telescoping equation, and I'll show you what I mean. Let's jump into the notepad. I think I'm going to want a little more space, so we're going to go to the next page. But let's ignore the square root and let's ignore the equal to 9 for a moment. If I take a look at 3 over 1, that's just 3. 3 over 1 times 5 over 3. This would be our answer if n was 2. Yeah. Well, that's, 3 times 5/3, that's going to be, you could grab your calculator, or you can realize that when we do fractions, we multiply top and bottom, and that these 3's here, we multiply the tops and multiply the bottoms, so these 3's are going to cancel out, and we're going to be left with 5 over 1, which is 5. Let's take it a little step further. We don't know where we're going to stop, but let's analyze this pattern as we go. Multiplying these 3 fractions, that's going to be even harder if we don't have a calculator or anything with us until we realize, oh, the 3's cancel. And now the 5's cancel, and we're left with 7 over 1, which is just 7. Can you make a prediction as to what's going to happen next time? We're going to go all the way up to 9, multiplying by 9 over 7. But most of these numbers are never going to matter in our final calculation. It's going to be 9 over 1, which is 9. So if n is 1, we get 3. If n is 2, we'll get a 5 out. If n is 3, we'll get a 7. If n is 4, we get a 9. And I wonder if n equals 4 is one of the possible answers. Oh, it is. Very nice. And b equals 1 is one of the possible answers. I guess if you messed this up and thought you were doing square root of 9 equals to 3. But I like making sure that they have answers that you might do if you are reading the question too quickly or doing your work a little too quickly. And then these other answers, 38, 39, 40, these are more respectable, and our actual answer shall hide somewhere in there. Okay? So when n is equal to 4, the fraction under the square root becomes 9. But now let's bring the square root and the equals to 9 back in. So 3 over 1, 5 over 3, yada, 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 all the way up to 2n plus 1 over 2n minus 1 is equal to 9. Well, let's square both sides. That'll get rid of that pesky square root sign. So we'll have 3 over 1, 5 over 3, 2 to the n plus 1 over 2 to the n minus 1 is equal to 81. And when we work this out, The 5s will cancel, the 3s will cancel, everything will cancel except that last one. So this expression is always going to be 2n plus 1 over 1 is equal to 81. And that's really just 2n plus 1 is equal to 81. Well, now we can work out what n is. Okay. So bring the 1 over to the other side. We'll get 81 minus 1, which is 80. And now divide both sides by 2. And we'll get n is equal to 40. And that was definitely one of our answers. I think it was C. But let's go back and double check. There it is, C. And if you fudged the calculation a little bit, maybe you thought it was 2 to the n minus 1, you would have gotten something like 39. So these other answers here are understandable, but our final answer is going to be C, 40. And that's a great example of a telescoping sequence, or a telescoping question, or a telescoping equation, or a telescoping problem. Because what happens is all of this stuff sort of collapses, and only the things on the end become visible in the final result. And this is sort of like those old-timey telescopes. I don't have one in this room, but sort of the ones that a pirate would look out of, and then he would, when he's done looking, land ho, you see, he buys the New World, and then he closes it all up. And this really long telescope, now it's just the eyepiece and the final piece. You stretch it out, you expand it to look, and then you collapse it like a telescope, or, well, actually, no, that was a telescope. Usually you think of telescopes to look at planets, but a telescope is really just anything that lets you look long distances. So it's collapsible, like a collapsible telescope, and that's what happens here. All these fractions multiplying together collapses into the single fraction of 3 over 1, or 5 over 1, or 7 over 1, or 9 over 1. And that makes our calculation so much easier. Okay? So that does it for question number 21. In the next video, we're going to take a look at question 22. I urge you guys to download a copy of the contest and try question 22 before watching that if you haven't already. And that said, I'll see you in the next video.